number 6 now. Okay, number 6, and this will be our first question today. Okay, so on number 6, we are dealing with logs. Okay, so whenever you're solving questions involving logs, then you have to know the laws that involve these things. Okay, you have to know the logs that involve these things. Okay, so logs have quite a number of laws actually. Yeah, they have quite a number of laws. Okay, so I hope you know some, because I'm going to be using those same logs here. Okay, so they're saying question A there, they're saying given that y is equals to log 3x, okay, find the expressions in terms of y for log 3, I have x there and 9 there, okay? Find the expressions of this in terms of y, okay? So it means whatever I have here, okay, whatever I have here, my aim is to make it into that form, okay? Whatever I have here, my aim is to change it into that form for log 3x, okay? So the property that we are going to use here is the property for when you are changing bases in logs, okay? So that property states that, okay? That property states that if I have a log a there, okay, with an x there, then I want to change it to log b, okay? If I have log ax there and I want to change it to log b, the property states that you write log b on top there, okay? It will be log b there, which is the new base side. Then you write your x in front there, okay? Then you say divided by log b again, okay? Then you write what was your base here, you write it in front, like that. Okay, so you have to know this rule. Okay, so it's a rule. Don't ask me how it came about. I also found it like that. Okay, so it's a rule. When you're changing bases, okay, when you're changing bases, it means if I have log ax and I want to change to log b, I just do log b of x and then log b of a. Okay, so you can see log b of x, log b of a there. Okay, so that's what I'm going to use somewhere there. Okay, and then again, on this same question, I can see another property, okay? And that property states that if I have log there in log b, then I have x there, okay? Then I'm subtracting with another log b, y there, okay? So as long as this log b and that log b, they are the same, okay? I can combine this, okay? And it will become log b, okay? Then I subtract what was here. I mean, I divide what was there and there, okay? So this property, it means it will give me x over y, okay? So as long as you have the same base, logs to the same bases, and you have a minus, it means you can divide those that are there, okay? If we had a plus there, if I had a plus there, it means it would have been log b, okay? So I'm just going quickly through the properties before I solve anything, okay? It will be like that, okay? So if I had a plus there like that, it means if I simplify that, as long as they have the same base, I'm just going to multiply x with the y there, with the same base, okay? If I had a minus there, it means I'm going to divide x over the y there, okay? So having now enlightened you on these 3 properties of logs, we can solve this question, okay? So they are saying we have y is equals to log 3x, okay? We have y is equals to log 3x, okay? Then they are saying simplify log 3, okay? You can see there, they have x over 9, okay? So you can see this one here. You can see the property that I was talking about here, okay? When you are dividing there and you have the same logs, it means you're just subtracting there, okay? So it means whatever is here there, I can also write it as log 3, okay? Log 3 there, then I say x, then minus log 3, 9, okay? It means it was like this at first, okay? Then what is log 3x there? You can see that log 3x is just y, okay? So it means there I'll replace with y is minus, then here I have log 3, 9, okay? So this 9 here can also be written as 3 to the power 2, okay? So I'll introduce another property here, what that states that whenever you have log a, b to the power 2 there, okay? It means you can drop this power in front there, okay? And it will become 2 log a, b, okay? So I've dropped the power. So there, I said that's 9. You can write it as 3 log 2, okay? So I'm going to drop this power in front there. So meaning, what do I have there? I have y minus 2 log 3 of 3. Okay. And whenever you have log a of a, okay, this is an identity, it's always equals to 1. Log a of a, so as long as you have two numbers there that are the same, okay, like here, log 3, 3, okay, it means that is equals to 1. So meaning this is y minus 2, then multiplied by 1. Okay, so in short, that is just y minus 2. Okay, so we've simplified, we put it in terms of y. So I don't know if there are any questions there before we go to the next one. Anything that I need to clarify here? Hello? Anything? Or I can move to the next question.
So can you repeat everything?
Okay, so logs, in simple terms, for you to solve questions on logs, you have to know the properties. Okay, so I've given quite a number of properties here. Okay, so you can say this is the first one. You can say that is the second one there. Okay, so I said whenever you have log a b squared, it means this squared here, you can drop it in front of the log, so it becomes 2 log b there. Okay, this property. And then the other property is when you have log a of a, okay, log of identical numbers here. Okay, whenever you have the same numbers there, you just know that that log is 1. Okay, then apart from that, I explained these two rules here. I said when you have log b of x being subtracted by log b of y, okay, it's the same as writing log b, then you divide the x there with the y there. Okay, so log b x over y. Then if you have a plus there, it means you are multiplying this x and the y. Okay, that one down here. Then we also have this one for changing bases. Okay, if I have log a and I want to change to log b, I just write log b of x, which is this number, and then I write log b of the number that was the base. Okay, so following those principles, that's how we ended up simplifying this. Okay, so putting in mind that we have been given that y is equals to log 3x. Okay, so this log 3x over 9, it means they were subtracting, okay, 2 logs that had x and the 9 there. Okay, so log 3 of x minus log 3 of 9. Okay, so this log 3x is just y according to them. Okay, from what they have given us in the equation. So we replaced this with y. Then we said minus. Then this is log 3, 9. Okay, this 9 can be written as 3 squared. That's what I wrote there. Okay, so now when it's written 3 squared there, I use this property here of dropping the power. Okay, so the power drops to the front like that. Okay, so it will be y is equals to 2 log 3, 3. And then this log 3, 3, we said when you have the same numbers, it's just 1. So it means 2 multiplied by 1 there. And then you have finally you simplified y minus 2 there. Okay, so let me solve the other one. Okay, so the other one there is log 3 of root of x. Okay, so log 3 of root of x, how do we simplify that? Okay, so log 3 of root of x. Okay, so I remember when we are learning about that, we said the square root is just a power half. Okay, so meaning this one is equals to log, okay, 3, then here we have the x, which is raised to a power half. Okay, so square root of x is the same as x to the power 1 over 2, power half there. Okay, so having this now, it means we can drop the power there. Okay, we drop the power. So it means we have half, then log 3x. Okay, and then this log 3x, okay, is just what? It's just y. Log 3x there is just y. Meaning when you simplify that, you just get half y, like that. Okay, so that is the answer there. Then the follow-up question says, okay, we've written each of them in the simplest form. Okay, then they're saying hence or otherwise, meaning using the answer that you've got here and there. Okay, solve this equation here. Okay, solve this equation. Okay, so that equation is written as, where's my board? Okay, so that equation is written as 2 log 3, okay, x over 9. Then you have log, hey, what is happening to my pencil? Log 3, okay, square root of x is equals to 2. Okay, so we are solving this question. So how are we going to solve this question? We're just going to replace whatever value we found for this and whatever value we found for this. So this 3 log x over 9, we found that it was what? It was y minus 2 there. Okay, then this log 3x, we found that it was half y. Okay, so we are going to replace that. Okay, so we say 2, okay, Then this log 3 minus y, we found that it was divided by y, we found that it was x, I mean y minus 2, okay? So this guy here is representing this whole thing here, okay? Then we say minus, then what is it? Log 3 of x, we said it was just half y, okay, is equals to 2. Okay, so here now we can solve. So it means here we have 2y minus 4, then they have a half y, okay, is equals to 2 there. What is our y now here? Okay, like terms together, 2y minus half y is equals to 2 plus 4. Okay, so I have 2y minus half there. What am I going to get? I'm going to get 3 over 2y is equals to 6. Okay, so from there now, this is the same as 3y over 2, okay, is equals to, I'm supposed to write 2 here, okay, is equals to 6 over 1. Then from there, you can cross multiply. I have my 3y there is equals to, what is 2 multiplied by 6? It's 12, okay? So what is my y here? My y is just 4, okay? So I found my y there, okay? So after finding my y now, I take it back to this equation here and solve for my x, okay? So remember that my y, okay, is just equals to, then my screen has gone. Wow, ish, what am I going to do now? Okay. Stop sharing screen. Okay, so this is my y here, we found 4. But in the original equation, remember my y was equals to log 3 of x, okay? So my aim here is to find this x. So how am I going to find it? I'm going to replace wherever there's y there, I'm going to put 4, okay? So it will be log 3 of x is just equals to what? 4, okay? Then from here now I can find this my x. How am I finding my x? I'm taking this guy here into exponential form. And how do I take to exponential form? We said we use the mnemonic BAM, okay? Not what you're thinking about, okay? So BAM means base to the power answer is equals to what is in the mid, okay? So base, which is this 3, to the power answer there is equals to what is in the mid. So the x is what is in the mid, okay? So base to the power answer, which is 4, is equals to what is in the mid. Okay, so what is 3 multiply 3 to the power 4? Is it 81? 3 times 3 times 3 times 3. Okay, 81. It means my x there is just 81. Okay, so you can see that logs are beautiful. As long as you know the rules, then you can find any question that they can ask you. Okay, so that's how you go about solving that question. Okay, so let me pick one more question, then we call it a day. Okay. All right. Okay, so all these properties, they are hiding our questions here. Can wrap them. Okay, so let me pick another interesting question from these log things so that we tackle it together. Okay, so I think my screen is not visible. Okay, where are you, screen? Okay, so from here now, there's B there. B states like what? I want an interesting question. Why there? Okay, and then okay, here's what I solve what end of tutorial. All right, so I is supposed to, okay. So let me solve which question here. Okay, you can help me choose, guys. I solve which question?
C. C1.
Okay, this one.
Everyone. Yes.
Okay, so they're saying show that the equation 2 log 2y, okay, is equals to 5 minus log 2x, okay, where x is greater than 0, and then y is also greater than 0, that this equation here that they have been given to us, okay, can be written in the form y squared k over x, where k is a constant to be found, okay, where k is a constant to be found. Okay, hence or otherwise solve whatever we have there. All right, so let's get into it. Okay, so how are we going to solve that question? How are we going to make this one here be in this form. Okay, so it's very simple. We are just going to follow the rules of log. Okay, the one who has a question you can ask. Okay, so here I have you can ask the one who has a question.
That is log 10 part of it.
Is log 10 what?
Part of it. One of the rules.
Is log 10 one of the rules? That's your question? Hello?
Yes.
Okay. You're saying is log 10 part of the rules? Yeah, there's a rule for log 10. Okay, but it's just a simple rule. It means whenever you see a log without a base, just know that it's log 10. Okay, and this can also be written as LG. Okay, so whenever you see something without a base, it's log 10, or whenever you see log written as LG, that is log 10 again. That's the rule that governs the log 10. Okay, so this equation I have 2.
So that one is equal to what?
Which one?
As in, is it 1 or?
Which one? This one here.
Yes.
Yes.
Okay, this one I was saying another way of writing log 10 is LG. I wasn't saying it's equal to anything. You've gotten what I said. I was just saying another way of writing this is LG, not that it's equal to LG. Okay.
Okay.
Okay, so now let's solve that question. I have 2 log 2 y minus, is equals to 5 minus log, okay, minus log 2x, okay, 2x there, like that. Okay, so we are trying to make this equation appear in this form, where I have my y squared there is equals to k over x. Okay, so you can see that from this, we are going to come up with this. Okay, math is a bit confusing, right? So how does that whole thing end up into this thing here? Okay, so we have to follow the rules for the logs. Okay, so let's begin. Okay, so there I have a log 2 there. Even there I have a log 2. Okay, so I can make the like terms come together. Okay, so I'll say 2 log 2y. Okay, then I get this log, I put it to the other side there to become plus. Okay, log 2 there, x. Okay, what's happening to my keyboard? X is equals to what has remained there is just 5. Okay, then I can apply that property for adding here. Okay, because I said when you're adding and you have the same base there, you can just simply multiply whatever you have there. Okay, but before I multiply, I want to take these 2 back up there. Okay, so here that I just have a log, so it will be log 2 there, y, then that 2 goes up back there. Okay, remember it can drop, it can also go back. Okay, so plus log 2 there, I have my x is equals to 5. Okay, so from here now we can apply that rule for adding logs. So log 2 is simply equals to y squared over x. Okay, y squared over x. You can see that our answer started appearing, right? Okay, so our answer started appearing, something like that. Okay, so from here now, what do? We convert this into an exponential form. Okay, we said, how do we convert to an exponential form? We use the mnemonic BAM. Okay, so this BAM means that base to the power answer there is equals to what is in the middle. So this is our base, this is our answer, and what is in the middle is this. Okay, so meaning that y squared over x, okay, is equals to base to the power answer, meaning 2 to the power 5. Okay, so what is 2 to the power 5, guys? So we have y squared there over x. Then what is 2 to the power 5? Hello? What is 2 to the power 5, guys? No one knows. What is 2 to the power 5?
64.
64. Okay, someone says 64. Is it 64? Or is it 32?
32.
Okay, 32. So it's 32. So there are 2 to the power 6. That's 64. Huh? Someone is still saying 64. Huh?
Yes, it's 64.
It's 64. Are you sure? 2 to the power 5, it's 64. If you multiply 2 times 2 times 2 times 2 5 times, what are you going to get? you're going to get 32. Okay, so you should revisit the calculator. So you are going to get it 32. Okay, so we can see that from this, the equation that they wanted us to find, this what is this? This y squared k over x is started to appear. Okay, so what do you do for you to find that y squared? It means you just multiply, okay, or divide by x on both sides. You multiply by 1 over x, or you simply divide by x. So when you divide this by x, it means you only have y squared. Then is equals to, then you divide this 32 by x. Okay, so you can see that this 32 here was that value that they were referring to as k. Okay, so you've expressed this, and that's it. Form that they want. This one here. Okay, you can see that from this guy we're having that guy. It seems impossible, right? But it's very possible because we are dealing with logs. Okay, so now after solving that, okay, they're saying hence or otherwise solve the simultaneous equation. This one's here. Okay, so immediately you see the word here, hence or otherwise in math. Just know that you can't solve this question without knowing the previous question. So the answer that we've got here is what will help us solve that. Okay, so you can see that I have the same expression there. Okay, which is that which we expressed in this form. Okay, so that expression is just y squared 32 over x. Then the other one that I have been given now is just log x y is equals to minus 3. Okay, so I also changed that log x y is equals to minus 3. I turned it into an exponential. So don't forget your BAM there. Okay, base to the power answer is equals to what is in the middle. So meaning my y is equals to base to the power answer there. Okay, so it means this is your equation 2. Okay, this is your equation 2, and then this is your equation 1. Okay, so you can now solve this simultaneously with this. Okay, so y is equals to x to the power negative 3 there. Okay, so it means wherever there's y here, you put that. Okay, wherever there's y there, you put that. So meaning y squared is equals to 32 there over x. Okay, then wherever there's y, I'm going to put this. Okay, so meaning I have x to the power 3 there in place of that y. Okay, is equals to 32 over x. Okay, so what do I do here? I multiply the powers, meaning x is to the power minus 6 is equals to 32 there over x. Okay, then what do I do there? I cross multiply. Okay, cross multiply. It means I'm going to have my x to the power 6 multiplied by my x there. Okay, is equals to 32. Okay, why have I written 35 there? So this is 32 there. Okay, so this is 32. Okay, so what do I have on my left there? I have x, okay, and x. So same basis, we add the powers, meaning this is going to be x. What is minus 6 plus 1? It's just to be minus 5 there. Okay, is equals to 32 there. Okay, so after that now, you can actually represent this as 1 over x to the power 5. Okay, is equals to 32, because the negative power means you write the same thing over 1 like that. So 1 over x to the power positive 5 now. Okay, then after that you can say cross multiply. So when you cross multiply, you're going to have 32 x to the power 5 is equals to 1. Okay, then after that divide both sides by 32. It means x to the power 5 there will just be 1 over 32. Okay, 35 32 there. Okay, then there now you can find the fifth root of this and the fifth root of that. Okay, so fifth root of x to the power 5, it means fifth root and the root and the power there will cancel. Then this side you have the fifth root of 1 over 32. Okay, 32, I almost wrote 35 again. So meaning that will cancel. So you have your x is equals to, okay, what is the fifth root of that? But just from finding that it is 2. Okay, we say that 2 to the power 5 is 32. Okay, meaning the fifth root of 32 is just 2. So meaning your x there will just be half. Okay, after finding the x, then you can go back and find your y. So your y was equals to what? My y was equals to x to the power minus 3. Okay, so my y is equals to x to the power minus 3, meaning half to the power minus 3 there. Okay, so y is equals to, whenever I have a negative power, meaning you can write 1 divided by the same thing, okay, now with a positive power. So is equals to 1 divided by What is 1 to the power 3? It's just 1. Then what is 1? 2, I mean, to the power 3 is 8. Okay. So it means it's equals to 1 multiplied by 8 over 1. It means your y there will just be 8, like that. Okay. So x, what did we find? We find x was half. And then y, what did we find? We find our y was 8. So that is the final answer there. Okay. So do I have any question before I end the class?
Thank you so much.
So that is the end of our class, guys. Thank you for attending and have a...
Sorry. When is the next class? When is the next class?
Tomorrow. The classes are Monday to Friday.